Welcome to this deep dive into Java 8 interface enhancements. In this presentation, we will be exploring the powerful feature of default and static method in interfaces. These additions represent a significant evolution in Java programming, allowing developers to extend interfaces in a backward compatibility way while also provide utility methods tied directly to the interface itself. Today we will break down the reason behind these changes, the syntax and uses, real world applications and best practices, along with some code example to solidify your understanding. Let's get started. Traditionally, Java interfaces could only define abstract methods. This approach worked well for many use cases, but as Java application grew larger, it created a significant challenges. Adding new methods to an existing interface could break existing code implementations. Java 8 addressed this issue by introducing default and static methods in interfaces. This change enables Java developers to evolve interface more gracefully while keeping code backward compatible. With this new capability, interfaces have become much more versatile and powerful. So, what exactly is a default method? Well, in Java 8, a default method is a method within an interface that provides a default implementation. The keyword default is used to define these methods, allowing you to extend existing interfaces without forcing all implementing classes to override the new method. This addition enables smoother interface evolution and is particularly useful for libraries or frameworks where backward compatibility is crucial. Let's take a look at the syntax for creating a default method. Here we have a simple interface called myInterface with a default method named show. Notice the use of the default keyword followed by the method body. The implementation is available to any class that implements this interface, as seen in the example where my class does not override the show method but can still call it. This allows the interface to provide a basic implementation while leaving room for subclasses to provide custom behavior. Use cases for default methods. Default method open up several compelling use cases. One of the most common is interface evolution, adding methods to interface without breaking backward compatibility. Additionally, default methods support multiple inheritance of behavior, which allows a class to inherit behavior from multiple interfaces. They can also be used to enhance functional interface by providing default implementations for helper methods. These benefits make default methods a versatile tool in a developer's toolkit. Now let's move on to static methods in interfaces. Unlike default methods, static methods in interfaces are defined with the static keyword and are invoked directly on the interface rather than on an instance. This is particularly useful for utility functions that are closely related to the interface but do not operate on an instance. By grouping relevant static methods together with the interface, Java developer can keep the code more organized and modular. Here, how a static method is defined and used in an interface. In this example, the my interface has a static method named print hello, which prints a message to the console. Notice how we call this method directly on the interface rather than on an implementing class. This approach is ideal for utility functions or factory methods that create instances of the implementing class. Use cases for static method. Static methods are particularly valuable for utility methods that are logically tied to the interface. For example, they can provide helper functions for working with the interfaces, type or factory methods that create new instance of implementing classes. In this slide, we see a factory method example in the shape interface, where a static method creates an instance of a circle. This approach keeps the code clean and encapsulated the factory logic within the interface. One challenge with default method is dealing with the diamond problem, which occurs when a class implements multiple interfaces that define the same default method. Java provides a straightforward resolution. You can override the method in the implementing class to resolve the conflict or specify which interface default method to use with the interface dot super dot method name syntax. In the example here, we have two interfaces A and B, both with a display default method. The class myClass resolves the conflict by explicitly invoking the display method from interface A. Best practices for default and static methods. While default and static methods are powerful tools, they should be used judiciously. When adding default method to an interface, aim to keep them simple to avoid complicating the interface. It's also crucial to avoid overusing default methods, as this can lead to cluttered and confusing interfaces. For static methods, reserve them for utility functions or factory methods that are directly related to the interface. Following these practices will help you maintain clean and maintainable code. In real world applications, default and static method have been used extensively to enhance existing libraries. The Java Collections framework, for instance, added several default methods like for each in the iterable interface, providing a new capabilities without breaking existing code. Similarly, the stream interface include static methods for stream creation, making it easier for developers to work with functional programming paradigm in Java. This changes reflects the practical benefits of default and static methods. Despite their advantages, default and static method come with some risks. Overusing default methods can make interfaces difficult to understand, especially when multiple interfaces define the same default methods. Carefully consideration is needed when deciding whether to add a default method to an existing interface. Additionally, we be aware of backward compatibility issues when clients rely on specific default behavior. Following best practices can help you avoid these pitfalls and make this most of Java 8's enhancements. To wrap up, default and static method bring significant improvement to Java's interfaces, allowing developers to extend and evolve interfaces more smoothly. These methods provide a powerful way to add behavior, enhance libraries, and implement design patterns. By understanding how and when to use these features, you can make your code more flexible and maintainable. Always follow best practices and remember to balance the use of default and static methods to keep your interface clean. Thank you for watching this video. If you really enjoyed this session, then don't forget to like and subscribe my channel as a small token of appreciation.